Hello guys, welcome back. In this video we will be learning KTG and thermodynamics. It's of two chapters in together in one shot. This is gonna be very easy chapter. Unlike other chapters, it's gonna be on understanding and just formula applying. That's it. Okay, let's get into the chapter, and I'm not gonna write each and every single thing because it may take time if I write. So I'm just gonna explain like this. So yeah. First, in this chapter, it's actually based on the assumptions. We have some pre-assumptions and then we do stuffs inside that. Okay. So all the particles is a random, is having a random motion. Like there are a lot of particles here and this will go in this direction, and there is a kind of random motion happening here, and all collisions are elastic. The elastic collisions means during the collision it doesn't lose its energy. That's basically called elastic collisions, and all collisions doesn't lose energy in this case. Okay, and delta p will be equal to 2 mv. Okay, which means change in momentum is basically 2 mv. Fine. Size of the molecule is very smaller than the size of the container. Okay, there is no interaction between the molecules. So basically k q1 q2 by r is the potential energy formula, if you remember. So if there is no interaction between the particles, then potential energy will be zero. It is very important, remember it. Whatever be the what's this okay whatever be the energy, that will be in the form of kinetic energy. So basically it doesn't have potential energy, which means it has only kinetic energy. So whatever energy which you see inside this will be actually kinetic energy itself, and it has no effect of gravity in this. So basically effect of gravity is neglected. So basically if you see the particle, if it has gravity, it will go like this, like it will go down, right? The force when acts downward, it will drastically drag it downward at some point, but in this case it goes straight. Okay, so this will be the correct motion and this will be a wrong motion. Okay, and it obeys Newton's law. Fine, these are the things which are the assumptions which have been taken. So let's see some question of which clears our concepts about average speed and velocity, root mean square, and then most probable speed. Suppose there are 10 molecules having speed 2, 4, 4, 5, 3, 2, 4, 0, and what's that? 5. If you just want to find the average speeds, it's just the same formula. You're just gonna add every speed and divide it by the total number of speeds. This is basically the simple formula which you have been learning since grade 2. But VRMS is pretty different. It may be new for some people. So RMS does mean root mean square. So basically root it and take a mean of it and square it. That's basically this. So it comes like this. So this means average velocity. Fine, take average velocity and square the velocity and root. So what do you think? While taking the average, square it. Okay, it's like this, it's not like this. Fine, hope you understand. So basically square the velocities like this and then take a root of it and then divide it by the total number. Fine, and what is most probable speed? So most probable speed is simply the number of speed which is actually repeated the most. So in this case most probable speed will be 4 because it is repeated the most. Okay, and let's see some important results. So the average velocity of all the particles in this container will be 0. Okay, because see, basically if one particle will travel like this, another particle will travel like in the opposite direction, and they both will cancel out. So in that case the average velocity will be 0, and Vrms is equal to root 3 RT by m. So where T is temperature in Kelvin and m is molecular mass of the species. Okay, so yeah, so R is I think it's 25 by 3 Reisenberg constant, if I'm not wrong. So average velocity, average speed will be root 8 by pi RT by m. Fine. Okay, these are the formulas, just remember it. So R value is also given here. Okay, and remember this relation is very important, which is V is directly proportional to the root under temperature. Fine. So basically Vrms is proportional to it, V most probable is proportional to it, and average speed is proportional to it. So basically, so like that, if you take, so Vrms will have the maximum value compared to V average and V most probable. Fine. We also have this important formula. This, like, most of the questions will be based on this formula. PV is equal to nRT. If you want to change in the terms of density, it's going to be PM is equal to density RT. Okay. Okay, let's see some graphs. If you understand these graphs, I swear you can almost attend every question in JEE mains questions, in JEE mains. Okay, so PV is equal to nRT. From this we are going to draw certain graphs. Okay, so as you can see, this is P versus V graph, and simply it's going to be a straight line. Okay, let's say the initial volume is V0 and the final volume is 4V0. So according to PV is equal to nRT, if V0 changes to 4V0, how much will be the temperature will change? As you can see, here P0 is constant, here pressure is constant. So when making pressure constant and V changes to 4V0, then T will be changing to 4T0, right? As simple as it is. So 4T0, it will be changing from T0 to 4T0, right? So pressure will be constant and volume will increase, temperature will increase, and velocity RMS will also increase. Okay, so when keeping pressure constant, it will be an isobaric process. Okay, how will VRMS depend? As I said, it depends on root T, right? So since it depends on root T, so root temperature root T in B by root T in A simply gives you root 4, and this will be equal to 2. That's how you will find it. Fine. Now let's talk about this. So basically volume is constant here, and pressure is decreasing and temperature is also decreasing. So when volume is constant, pressure is decreasing, temperature will definitely decrease. So this process will be basically called as isochronic process, where volume is constant. Okay, so isothermal process is simply when temperature is constant, that you will be calling it as isothermal process. And same isobaric process, and you should have gotten better idea how to actually analyze the graphs as of now. And then remember that adiabatic process. Adiabatic process is a process where no heat exchange happens, which means delta Q, where Q is the symbol for heat, and that will be equal to 0. Okay. Okay, yeah. So let's see a question which clears all of your doubts, and it will give a better understanding of thermodynamics, a feeling of thermodynamics. So basically, this is a process which goes from A to B, and B to C, and C to D, and comes back D to A. Fine. So basically, these all things are only given. Okay, and the graph is given. Rest all the temperature things we need to find it. Fine, which is already written there, but we need to find it. Okay, and A to B, B to C, we need to analyze the graph. Fine. So as you can see, its temperature is going to be pressure is going to be constant, and this root volume is going to be constant, and this root pressure is going to be constant again, and this root volume is going to be constant. Fine. So basically it changes from V0 to 7V0, which means if temperature is initially was 100 Kelvin, which is already given, so this temperature will be 7 multiplied by 100 Kelvin, which is 700 Kelvin. As you can see here, the temperature is going to be 35,000 Kelvin. Why is it so? Because PV equal to nRT is the formula, right? So basically P is given as 5P0 and V is given as what? 7V0, right? Which gives you a round total of 35. 35 multiplied by 100 will be basically 3500 Kelvin, right? So this gives you this, and hope you understand this also. Okay, and What's special about this graph? It goes from A to B, B to C, C to D, and comes back to A, which means this is a cyclic process. This is a cyclic process, and this type of graph represents the cyclic process. So yeah, hope you would have analyzed this also. This is exactly what I said. Now if you understand what I said, basically the same answer is written here. Okay, and the next question is, let's take a container and fix a piston to it, and let's heat the gas, and the adiabatic wall. So adiabatic wall means no heat will exchange. Okay, so in this process it expands, let's say x distance. Okay, so what all will be the forces acting on the piston? This is the piston. Okay, so the pressure of gas multiplied by the area will give me basically the force exerted in this direction, and this direction also there will be a force exerting, which is called as pressure of atmosphere multiplied by the area. Can I tell that? So this both will be equal. I can tell Pg is equal to P naught. Okay, in this pressure is going to be a constant, right? So A will be getting cancelled, and Pg is equal to P naught, which means it is an isobaric process. What about in this case? Let's attach a spring of natural length, and you're gonna expand this x distance. So in this case you will get a formula like this, because both the pressure of the atmosphere and the spring force is getting added, right? So in this case the pressure will be Pg is equal to P naught plus Kx by A, which is not an isobaric process because both side pressure is not equal. Pressure is not constant. Hope you understand. The next is again a graph. Okay, so what is this graph about? So basically P versus pressure versus temperature graph, and we are seeing something like this. What does it represent? So basically it represents volume is constant. Okay, it's an isochronic process. Temperature will increase, pressure will increase. Why? How we found that volume is constant? It's basically simple, because we know the formula PV is equal to nRT, and we have given that pressure is going to increase, temperature is going to increase, and we can also like rejumble it like PV is equal to nR by Vt, right? So this is an equation of a straight line, and if you see this will definitely be the slope, right? This is the slope. So in that case, n is constant, r is constant, then v will also be n constant, because any point if you take the slope, it's going to be the same value. So in that case volume will be constant, and that will be an isochronic process. Similarly, if you take in this way, simple do the same thing, and you can see it's going to be an isobaric process. So the next thing is work done by gas. If you have a basic idea of work, energy and power, you would have probably understood this by just seeing it. So basically we know that pressure of gas, force is exerting here in this direction by the pressure gas. Okay, so in that case, let's say dx distance have been expanded. So work done by the gas will be the integration of f dot dx. Do you agree? And what is the force acting here? Which is Pg dot A, if I'm not wrong. Okay, so A and dx will be converted into dV. Do you agree, guys? So this will give me a formula. Work done by the gas will be equal to pressure of the gas. Remember, this is very important. Pressure of the gas, not the total pressure, not the net pressure. It's pressure of the gas multiplied by the dV. Okay, and its integration will give you the work done by the gas. Okay, so basically when volume increases, so in this case volume increases, right? So that in that case work done will be positive. When volume decreases, work done will be negative, and when volume is constant, work done by the gas will be equal to 0. Fine. So which does mean if they have given you a PV graph, the area below the curve will represent the work done by the gas. Okay, cool. Okay, so let's see some questions. So basically this is an isobaric process, which we have told earlier, Pg is equal to P naught. Yeah, This is the isobaric process, and work done by the gas we need to find. So PdV is the formula, and we need to find when it expands from 0, let's say take this position as 0 to L naught. Fine. So yeah, integrate it, apply the limits and find the value. I don't think this is hard. Now this case, we have seen this how this formula came, and we have done all the things. But in this case we need not to take all these values. We need to take only the pressure of gas multiplied by the area, which is equal to P naught A plus Kx. Okay, this is the opposing force and this is the opposite force, so which both are equal to the Newton's laws of motion, and if you just manipulate it and you will get this answer. Okay, just apply the limit 0 to L naught and put the value I said earlier and dx, integrate it, find the answer. Fine. The next question is like P is equal to 12V to the power 5, the work done by the gas if gas expands from V naught to 2V naught. Okay, so if the gas expands from V naught to 2V naught, the temperature will change from T naught to wait, first we need to find the pressure. So 2V naught, P naught will change from P naught to how much? It's to the power 5, right? Sorry, this question is not about that. Fine. Work done by the gas. Okay, they are asking work done by the gas. Okay, so work done by the gas is simply P dV, which is equal to, see, basically they have given dV, right? So in these cases, so remember this relation, never forget this. These two get combined together and then form dV. Okay, so if dV is needed, you just use dV. So basically P is given as 12V to the power 5 in terms of V itself. So in that case, you need to use the limits as V naught to V naught and then just integrate it and find it. So again, this is the same question, just integrate it. This is a question of integration. Fine. Okay, and what about this? Initial is given as P naught, V naught, T naught. Okay, this is the question where what I said. Fine. So P is given as 3V square, right? Okay, final pressure will be equal to 4 P naught. How am I saying this? Just apply the value of 2 V naught inside this equation. So what will you get? 4, right? Because V square, sorry, not that equation, apply in P is like see I'm just messing it up. So basically P is equal to 3V square, right? So basically 3 is a constant, so just remove it. 3 is directly proportional to P V square. Okay, so in that case I can tell P final will be equal to 4 P naught, right? So similarly temperature final will be equal to this multiplied by this, which is equal to 8 P naught. So now it is easy to find work done by gas, same formula P dV, and integrate and apply the limits and get it. Okay, now work energy theorem. This is I just want to remember you that this is thermodynamics, not work energy power chapter, but you can still see lot of work related question. Of course it is, lot of work related questions will be there in thermodynamics. That's all thermodynamics is all about. Fine. So just to remember you guys that what work energy theorem is, work done by all the forces will be equal to the change in kinetic energy. In this case, in the container's case, work done by the gas and work done by the atmosphere is the only work which is done in a ideal case. So that will be equal to the change in kinetic energy, and we know that the work done by the gas is gas minus, where the work done by the atmosphere is basically P naught A L naught, right? So the distance is L naught is equal to 0. Fine. So work done by the gas will be equal to P naught A L naught. Okay, now let's see another question. So basically spring is attached and it is lifted to a distance H. Okay, what we need to find they are. So work done by gas, they have applied a work energy theorem, work done by all the forces. In this case, the only force is not work done by the gas and work done by the atmosphere. They also experience spring force and the gravity because it is mass m. Fine. So all the force will be equal to the change in kinetic energy. Okay, this will be the equation. Okay, from this, if you want, you can find it. You can also do it in the previous method which I've said, which is we can find anything. Basically, this is not a question, you can find anything. So if the values of this and one variable is given, you can find the one variable also. Fine. You can also do in the previous way, which is pressure of gas multiplied by the area is basically the force, and mg and p naught a and kx will be exerting force on this direction, and this will be the correct equation which denotes it. And just integrate it, like this moves from 0 to h and this moves from p naught a, right? It also moves from 0 to h and this also moves from 0 to h. Fine. So just integrate it and get the answer. It's simple, both will be the same answer if you see it. Now this type of question you must have seen it earlier in the lecture. So basically, if V is 2 times, so what will be the pressure? It's basically 4 times, because take this as constant, P will be directly proportional to V square, and this will be 4 times, this will be 8 times. If this is V naught, P naught, T naught initially, what will be the final? So V naught to 2 V naught, this will be given. So you can find the P naught to 8 P naught, and this all things are like easy, I hope so. And remember, this is directly proportional to root T, right? VRMS. So in that way, you can also find this. Just pause the video and try to do it by yourself. These are like easiest one. Okay? Sorry, some problem has occurred. Sorry for the misconvenience. And then we'll be seeing something called degree of freedom. Okay, number of independent way the molecule can have energy is called a degree of freedom. From this, we'll go a little faster because I hope you guys know about this. So the number of independent way in which the molecule can have energy is called degree of freedom. So basically, there are like different types of gases, which is monoatomic gas, diatomic gas, and triatomic gas. Those all things. And monoatomic gas will, for example, let's say helium, neon, and this will have degree of freedom which is 3. Okay. So basically, why do I say 3? It's just because if there is a dot like particle, it can move in Vx direction, Vy direction, and Vz direction. Right? These 3 direction it will move, so the degree of freedom is 3. Why is it depends on Vx, Vy, and Vz? It's basically all the energies which is in this will be basically kinetic energies. It won't be potential energy, will not affect this. So since kinetic energy formula is 1 by 2 mv square, it only depends on the velocity, and these velocities will be in 3 direction. That's why degree of freedom is 3. So diatomic gas, so basically it is of 2 particles. Since it is of 2 particle, it will also involve the rotational and translation motion. So it will be Vx, Vy, Vz plus omega x, omega y as 3 translation motion and 2 rotational motion. At high temperature, vibrational degree of freedom will also get added, which is of 2. So in high temperature, the degree of freedom of a diatomic gas will be 7. What about triatomic? If the triatomic particle is linear, degree of freedom will be 5. If it's not linear, degree of freedom will be 6. Okay. Now let's see Maxwell's equipartition law, which says about internal energy. Remember that internal energy is an energy which only depends on temperature. Okay, and this is the formula of internal energy. Mark me, this is very important formula. Okay, so basically where U is the internal energy, N is the number of moles, and F is the degree of freedom. So all the given informations will be given in the question itself. Sorry, all the needed informations will be given in the question itself, so no worries. Okay, And another formula will be, if you want in delta terms, only changeable value is temperature. So NFR delta T by 2. Remember this. Fine. So basically, as I said, it depends on only temperature. When temperature increases, delta U will be positive and internal energy will basically increase. So when temperature decreases, internal energy will be decreasing and delta U will be negative. And when T is constant, U also will be constant and delta U will be equal to 0. If T initial is equal to, this is the same thing which I'm going to repeat it again. If T initial is equal to T final, then U initial will be equal to U final and delta U will be equal to 0 in any process. Right? So next thing is questions again. We need to comment about delta U and work done basically. So in this case, temperature is increasing, right? So since temperature is increasing, delta U will be greater than 0. And what about work done? Work done is also increasing because work done is also positive because it goes from here to here, which means volume is increasing. And what I said, when volume increases, work done by the gas also will be increasing. Okay. Now what about temperature versus pressure? When pressure increases, it doesn't affect the work done by gas for sure. But when temperature is constant, which means, and pressure is increasing, okay, temperature is constant and pressure is increasing, which means volume should be should be decreasing for sure. Okay, so because PV is equal to nRT and we observe that pressure is increasing, okay, and temperature is constant. To maintain temperature constant, volume should be actually compensating the value which is done by the pressure, right? So yeah, so since that case occurs, work done is basically lesser than 0 and delta V will be equal to 0. Yeah, you can analyze these all cases too. Do it as homework if you want to get good marks in JEE mains. Okay, let's see some important results, which is simple results. So basically, work done by gas, when volume increases, work done by gas will be positive. When volume decreases, work done by gas will be negative. And when volume is equal to 0, work done by gas will be equal to 0 as well. So similarly in this, when temperature increases, internal energy will be greater than 0, and when temperature decreases, internal energy will be lesser than 0, and when temperature is equal to 0, internal energy is 0. Right? And delta Q, heat given or heat taken. This is basically called delta Q. Okay. First law of thermodynamics. Let's get into the chapter. That doesn't mean we didn't complete any part of the chapter. We have actually completed 1/4 of the chapter. Okay. So first law of thermodynamics, what it says, delta Q is equal to delta U plus delta W. This is important. Of course, first law is definitely important. And delta Q, heat given or heat taken. Okay. So what is the delta W? Work done by the gas. What is delta U? Change in internal energy, where delta U is equal to N of or delta T by 2. So now we need to understand something very important, which is called sign convention, because this is the thing which separates the chemistry thermodynamics from physics thermodynamics. Okay, so just don't get confused. Just study both the chapters as a separate chapter so that you won't get confused. So when volume increases, so these all things we have already seen. I think let's not waste much of the time. Let's see about delta Q. If heat is given to the gas or the system, the heat will be increasing and delta Q will be greater than 0. When heat is supplied to gas or the system, delta Q will be greater than 0. If heat is taken away itself is a negative quantity, right? So these taken away or rejected. So basically this delta Q will be lesser than 0. Okay, as simple as it is. So same thing which we have seen it earlier, but try to analyze the work done by the gas and delta U. What are its signs? Basically you have volume, temperature, right? So you can find this and this. And what about this? It's based on temperature. Sorry, it's not based on temperature, it's based on first law of thermodynamics. Just when both are positive, and we know that formula, what is the formula? Delta Q plus delta U plus delta W, right? So delta U plus delta W is equal to delta Q. If both are positive, delta Q will be positive, right? So yeah, so in this graph is basically very important. So yeah, it goes from A to B, B to C, and C to D, and D to A. This is the graph of pressure and volume. We need to find the signs of this. It's easy, right? So basically finding sign is, we need to see if volume increases or decreases for work done by the gas, and we need to see whether the temperature increases or decreases for internal energy, change in internal energy. And simply you can apply in the formula, first law of thermodynamics, and find the values, so find the signs. Okay, we also will see how to find the values also, but for now it's simply the sign convention. I hope you can do this. And when it shows positive, which means heat given, okay, when it shows negative, it means heat is rejected. Fine. So next thing is PV is equal to nRT. These all stuff I hope you know, guys. You know to analyze the graph, because simply this part delta U will be what? So this part, as I said, this line volume is going to be constant. Okay, this part I hope you know. When pressure is constant, in this part pressure is constant and the temperature increase, which means work done will be greater than 0 because volume also increases. The only relation, guys, PV is equal to nRT. You just apply in those and you can actually calculate it. Cyclic process. If there is a question of cyclic process and they have asked you to find the efficiency of the cyclic process, this is the only formula, guys. Work done net divided by Q plus, which means delta Q, which are only positive. For example, in this case, okay, we need to take only Q values of this. We need to reject that, because which is heat is rejected. In that formula, we no need to take those all rejected things. We need to take only the taken things, positive things, right? Given things, right? So yeah, you can see this also if you don't understand. It's simply work done by all the forces, and then simply the positive heat given moments. Okay, and then calculation of work done. Okay, so isochronic process, volume will be constant, work done will be 0. How can I say this? Hey, yeah, this is what you have studied this long. So volume will be constant and work done will be 0. And if you apply in this formula, you will get delta U is equal to delta Q. Okay, so delta U, you have a formula which is N of R delta T by 2. That's it. This is the formula for isochronic process, isochloric process. Now isobaric process, P is constant. So if you integrate a period integration of P dV, you can take P outside because it's constant and apply the limit V initial to V final, and this will be basically P delta V. Okay, now delta Q is equal to delta U plus delta W, and delta Q is given as R N R delta T. Why is it so? Because work done by the gas is equal to P delta V and N R delta T. Okay, because these two are constant, and the delta V will be, when P is constant, delta V have direct effects on temperature and it will become delta T. If you put this here, it will be something like this, and this will be the formula for isobaric process. Fine. Isothermal process, temperature is constant, delta U is equal to 0. In that case, delta Q is equal to delta W. So yeah, work done by gas is equal to nRT ln V2 by V1. Remember this. You can also write in terms of volume or in terms of pressure also, nRT ln P1 by P2. Fine. Work heat will be equal to change in work done by the gas. Fine. So yeah, this will be the graph. Just see the graph, and yeah, this is our first question. So 10 joules of heat is applied to a 2 mole of monoatomic gas. It is given like monoatomic gas. So for a monoatomic gas, I think the degree of freedom is going to be 3, and gas at 100 Kelvin at constant volume, find the final temperature. So 100 joules of heat, so delta Q is given, delta Q is given of heat is supplied to a 2 mole monoatomic gas. So N is given and F is given as 3 gas at temperature is given at a constant volume. It is given isochronic process. Chronic process. I think the spelling is wrong. Find the final temperature. It's easy, right? So yeah, this is the given things, and use the thermodynamics first law, and you can write 1000 is equal to NFR delta T by 2, which is the formula for an isochronic process. And then yeah, you can separate the delta TF minus 100 and you can find the answer. Next question is very important and interesting question. So delta Q heat is supplied to 2 moles of monoatomic gas at constant pressure such that the temperature of the gas is increased by, so it is increased by, so what do you mean by by? So when we say it's increased to, we say that increased to this much, which means it is increased to that quantity. So when they say increased by, which means it's increasing 100 Kelvin from the initial temperature. So in that case, delta T is given, okay, N is given, number of moles, and if the heat is supplied to the system of 2 moles of F is given, which is 3, at a constant pressure such that the temperature of the gas is increased. Okay, so applying the thermodynamics first law, I think the question is not that tough. I thought it will be tough, but yeah, it's easy question. Applying the formula and get the answer, but this is important type question. Okay, this is not a question, this is a concept, but I gave in the terms of question. Okay, let's say this is a cyclic process, guys. Okay, given 2 moles of monoatomic gas, temperature T at A will be 100 Kelvin. Find temperature at B, temperature at C, temperature at D. Arey yaar, this we have done already. If this is 100, this will be 5 V naught, right? So 5 multiplied by 100 Kelvin. This is not how we calculate. What I calculated is, I said earlier, I just say the way and answer of my calculation. 500 Kelvin, and if you multiply the 500 with 3, you will get 1500 Kelvin, and that will be here 300 Kelvin. So yeah, put in N of R delta T. So monoatomic gas and mole is given, just put in the formula and you can find delta U from A to B, delta U from B to C, everything. And you can also find the delta U net, which is coming to be at 0. For an cyclic process, delta U will be 0. It's an important point. For a cyclic process, delta U will be equal to 0 and Q net will be simply equal to work net. Fine. So area under PV graph will be basically equal to work done by the gas. And remember, anti-clockwise direction represents work done is negative, and clockwise direction work done is positive. It is so important to understand that for a lot of questions. Okay, I mean the direction means this one, they will definitely represent this one. So yeah, you can also find the things from that. Next thing is again, why is every question like same model? I hate it. So work done by the gas A to B. So P delta V, because P is constant, we can actually take this formula if you can agree. And then yeah, so what's there in this method 2? Work done A to B, the area under AB graph you can also find in that way. This area will basically represent the work done, the net work done. If you want the work done by A to B, you need to calculate the area under this. Fine. Area under AB for V naught, P naught. So what about B to C? Work done by B to C. So it's basically equal to 0. Okay. Delta U is 0 there. So it's equal to 0. Work done by C to D. So area under this, which comes all the regions, and D to A, which comes, and yeah, net work done will be basically area of A, B, C, D. Okay, so this is another value graph. If you can write it, you can also write it. So basically what we have find, they have written with the values. I think that's all they've done. P naught V naught value is equal to nRTA, right? Because P naught V naught T naught should come basically, but T naught here is TA. Those are initial quantities. So yeah, with this formula they found 200R. P naught V naught is equal to 200R, and they have calculated these all things. Okay, simple. Okay, why does it look the same? It's not the same. Oh my god. Okay, no problem. I think the both are of same kind of thing. I think for just for you to understand the thing, I've wrote this thing. Okay, next thing is PV graph and the same analytic stuff. So yeah, PV graph, this is gonna be volume constant. You need to understand that. What about unit? Unit will be always equal to 0 in a cyclic process. Okay, so UBC will be equal to 0. Okay, temperature constant. Temperature is not constant. Yeah, temperature is constant. And UCA, what about UCA? Internal energy from C to A. So when volume is constant, you get so basically this area, right? Just find the area, do it, and you can find A to be also just this area. It's not a big deal, bro. Guys, did you understand something? Like, find a mistake. This is a PV graph, and you can notice here that's going to be 100 and 300 Kelvin, which means it's not a PV graph. Instead, it's a PT graph. If it is a PT graph only, I have like said, like from B to C, temperature will be constant. I'm really sorry guys, because I've said a huge wrong thing. Okay, now it's perfect. So in this case, temperature is constant. I had a confusion. Now it's cleared. Okay, work done by A to B. So A to B, the work done is simply is equal to nR delta T if you see the conditions. Yeah, so nR multiplied by 200, that's what the delta T's value, right? So yeah, like this you can do for all process, because you can see different types of processes involved in this. So this is an isochronic process, and this is going to be isothermal process, and this will be an isochronic process. I'm really sorry, and this will be an isobaric process. Okay, so yeah, that's how you need to do. Like all the process things are involved, and you can also like find it like $1,000,000. It's not a big deal. Okay, so what about this, guys? What about this? For the first time I've seen some other different question. Delta V3 is equal to delta U1. Okay, I think they have represented three ways. Okay, let's say this is A and this is B. Three ways to go from A to B, and you can see the arrows are like this. So we need to compare the delta U in 1 and 2 and 3, work done in 1 and 2 and 3, and heat in 1, 2 and 3, which is greater, which is equal, those are things, fine. So in the first case, we can definitely say, if we draw something like this area will be covered most, because this is a PV graph. I can tell the most area covered curve will basically have the most work done. So this will be containing more work done than this, and then this is the graph, fine. What about delta Q? For that you need to find delta U, right? So what about delta U? It's temperature. This is going to be constant, which is T is equal to 0. So this will come in between. Okay, but everything you can see, it joins at the particular point, and T, so basically the difference will be delta T, and delta T is same for everything. Okay, in that case delta U will be also same for everything. So when these are constant and this is the order of work done, so simply this will be the same order of heat also. So that's written here. Okay, so P is equal to, next question, like P is equal to V square is given initially, N is equal to 2 moles, V initial is equal to 2 meter cube, monatomic gas and temperature. Yeah, I think this is not such a good question, right? But yeah, you can do this. We need to simply find the work done by the gas, internal energy and the Q net, right? So volume is changed from V naught to 2 V naught, okay, which means initial, if initially it's like 2 and finally it will be like 4, okay. When volume is changed 2 times, pressure will be is equal changed into 2 times according to this relation, and the temperature will be changed into 8 times. So you can actually basically write all the final things in this case. If it is changed 8 times, so simply 800 Kelvin. So yeah, this will be the temperature final. If you got temperature final, I hope you can get this equation right. So this is simply based on the delta T and F and R value. So yeah, moles is given, everything is given, so you can get this equation. So what about this equation? It's changed from V initial is equal to 2 to 4, right? So this is given, okay, this is given, these things are given, the above things are given, okay. So yeah, so 2 to 4, you just want to integrate it. Yeah, here we should have P, right? So we have converted into V square, so no problem, just integrate it and get the answer. And yeah, Q net also you can get it, just add both these things according to thermodynamics first law and you can get it. So yeah, let's solve some questions at home. I'm not gonna solve this, just take the question as a homework, okay. I'm just stopping for letting you take a screenshot. These are like exactly what I've thought in this. So a lot of questions has also been repeated, so I think there shouldn't be a lot of problem in this. So molar specific heat, so C is equal to delta Q by N delta T. This is the basically formula of molar specific heat, just remember it. So what is molar specific heat? It is amount of heat required to raise the temperature by 1 Kelvin of 1 mole gas. So simply the amount of heat required to raise the temperature by 1 Kelvin of 1 mole gas. It's simple. I hope you understand this English, okay. This definition isn't that hard, and if you just rejumble it, you will get a delta Q is equal to C NC delta T, okay, where C is the molar heat capacity, okay. So C is equal to delta, we take that relation here and we do some things to understand. So isothermal, C changes when in isothermal process, what will happen? Delta T is equal to 0. In this case, if it becomes 0, C will be moving towards infinity, right? It won't be equal to infinity, instead it will be moving towards infinity. In case of adiabatic process, delta Q will be equal to 0. So this C will be equal to 0 as well. Isobaric process, V is equal to, V is constant, okay. When V is constant, you need to change this term in terms of V, right? So this can be written as delta U plus delta W, okay, N delta T, and this will be equal to 0, and delta U by N delta T will be the equation, and this is exactly what it's written. I've expanded with the formula of delta U, and yeah, so I've done some cancellations, and V is constant, so yeah, will be equal to FR by 2. This is important relation, okay. This is important relation. This C will be equal to Fr by 2 in isobaric process, and that will be called as Cv, okay. When volume is constant, the specific heat will be called as Cv, okay. So delta U is equal to N Fr by 2 delta T is, right? So this formula, of course this is the formula of this, so I can write NCV delta T, okay. These both are same formula, just like modified things, okay. So yeah, this is important, just remember this, and this is also like convertible. I hope you can convert in like seconds. Next thing is isobaric, constant pressure. So in this we will introduce another term called Cp, okay. Do the same thing, like expand it and put NFR delta T, those all things, and NR delta T here. So N delta T is already given here. Okay, so yeah, so this will give you an formula called C is equal to FR by 2 plus R. Okay, is equal to CP. Okay, specific heat, molar specific heat at constant temperature. Okay, so it finally gives you an very important formula. Cp minus Cv is equal to R. Fine. Cp minus Cv is equal to R. This is just a subtraction. You must have evaluated it easily. If you just combine all the formula and think about it, you can get this formula very easily. I don't want to explain it. So yeah. So if you want, you can also just remember the formula, which is Cp minus Cv is equal to R. Fine. Isobaric process, same thing. You can also convert in this form. Delta Q is equal to NCV delta T. So how is this? So delta Q is equal to delta U plus delta W. If you change the delta U formula and delta W formula, it will be like this. And then delta Q is equal to NCV delta T, taking this, fine, plus NR delta T. Okay. So at last you will get this equation, and from the above equation which is mentioned here, you can actually get Cv plus R will be basically equal to Cp. Right, this is pretty wrong. Okay, delta Q will be equal to Ncp delta T. Okay, but in the before case we found that delta U will be equal to Ncv delta T. These are both different quantities, but represented in the terms of what? Molar specific heat, when volume and pressure are constants. Fine. So yeah, we have a question. This is a good question. The amount of heat required to rise temperature by 10 Kelvin at constant pressure of 2 mole of monoatomic gas. So what are the given information? The amount of heat required to rise the temperature by 100 Kelvin at constant pressure of 2 mole. So N is given, temperature is given, so delta T is given, N is given, monoatomic gas is given, which means F, N and T is already given. So yeah, it's just a specific heat question, and you can basically apply Cp here, where Cp we will be seeing that. Okay, let's take 5R by 2 now. Okay, this is basically down here. So as of now, Cp value for a monoatomic gas is 5R by 2. Just remember this, and 2 multiplied by 100. Simple. Okay, now yeah, just remember these values. This will be very useful. Okay, and this ratio will be given something like gamma. Okay, and these values are very important. Just remember these two values. I think it must be enough to basically find this value. Okay, so as we have compared this, delta of mono, sorry, gamma of mono will be greater than gamma of dia, will be greater than gamma of triatomic. Fine. Triatomic here is given for non-linear gas. Okay, and the relation of gamma to the degree of freedom with this is also important. Remember this, some questions will be definitely based on this when you solve the PYQs of JEE Mains or JEE Advanced, anything. So this is a CV mix. Okay, what if a lot of CVs are there? Okay, a lot of CVs, like 1 2, first one CV is this much for n moles, and second one CV is this much for n moles. You need to apply this formula. If you get CP mix, you need to apply this formula. When you get gamma mix, you need to apply this formula. When you need the relation between CV mix and CP mix, you need to apply this formula. This is just an average taking process with some modifications in that. That's it. Okay, and then yeah, 4 moles of helium plus 2 moles of oxygen, find CV mix, CP mix, gamma mix. This is an example of that. So 4 moles of helium. Helium is a monoatomic gas, which is 3R by 2 CV1. What about for O2? It's a diatomic gas, which is 5R by 2. So yeah, Cp also, the values are given in the table. If you go back and see, you can just get it. So how will you find? 3R by 2 multiplied by the mole plus this multiplied by 5R by 2 divided by the total moles. Simply you can get both the values. I hope this is an easy process. You can definitely do it. And let's talk about adiabatic process. Okay, so adiabatic process is the process where delta q is equal to 0. Okay, so in that case, when delta q is equal to 0, and if you apply in the first law of thermodynamics, you will get this equation, right? So this is a sudden process. Okay, so pv to the power gamma is equal to constant. So this is basically an adiabatic constant. I didn't tell the name in the table which is given above. So basically that is adiabatic constant, Cp by Cv. Remember, Cp by Cv, not Cv by Cp, it's Cp by Cv. Okay, so which is basically equal to 1 plus 2 by F. This is why I said that formula is important. Fine, you will be applying it here. So in adiabatic process, Cv to the power gamma will be equal to constant, which subsequently means you can actually convert it into any form you want. If you want in T, TV form, you can just put in PV is equal to nRT, and then if you take in terms of P, you can just, if you wanted to take 1V, you need to minus 1 here, and you will get the formula of this, right? So yeah, so work done by the gas is equal to nr delta T by 1 minus gamma. Remember it, again a formula. So what is nr delta T? N is a constant, R is a constant, and delta T is given, which means it's simply delta PV. Okay, this is just a formula, just remember it. The proof of it is not important, formula is very important. Okay, so pressure temperature relation for an adiabatic process. So again, TV relation is already given, so we need to find PV relation, sorry, PT relation. This is also very simple. Put a nRT in terms of V, PV is equal to nRT in terms of V, and then apply in the place of V itself is equal to constant. So simply you will get, wait a minute, I think I forgot something. Yeah, so yeah, you can manipulate this and you will finally get this formula thing. What you just need to remember is this formula. If you remember that formula, I think everything will be important. As you can see, like, there are a lot of questions in this, which is PV is equal to PV to the power gamma is equal to constant. What does it actually mean? So what type of questions will be actually asked? Because when it is equal to constant, why does it even matter? Where we are going to apply these things, we will be seeing right now. Okay, work done in an adiabatic process. So P1 V1, so this is, wait, so PV to the power gamma is equal to constant is equal to K. Okay, so when this relation comes here, you can just take in terms of P, in terms of K and V, and you can apply it in the formula PD, integral of PdV, right? So when you apply this, you can take K outside because it is a constant, and apply it, the limits V1 to V2, and you will get something like this. Do you agree? And then you manipulate it. Okay, okay, now K will be equal to P1 V1 gamma is equal to P2 V2 gamma to the power gamma. Okay, because it is equal to constant, which means the initial pressure will be equal to the final pressure, initial volume will be equal to final volume. So in that case, you apply this K value here, and yeah, manipulate it a bit again, like P2, and you will get P2 V2 minus P1 V1 will be, divided by 1 minus gamma. If you further manipulate it with the formula PV is equal to nRT, this and this will be constant, this will be the only value changed, and you will get the formula like this. If you want in PV, you can take this formula. If you want in delta T terms, you can take this formula. Fine. So yeah, let's get the feel of that. So a diatomic gas P naught V naught T naught compressed to compressed to a final volume V naught by 32 adiabatically, PF will be equal to. So yeah, diatomic gas, right? Which means, so yeah, this question is a pretty simple question. Like P naught V naught T naught compressed to final volume V naught by 32 adiabatically. So you need to understand that when it is an adiabatically, which means PV to the power gamma is constant. Okay, in that case I can write P1 V1 to the power gamma is equal to P2 V to the power gamma. Fine. So simply it is given, the initial thing is given as V naught, P naught V naught. Fine, I'll write P naught V naught. And what is the um, gamma value for diatomic gas? You can either remember in the from the table or the formula, which is 7 by 5. Just put 7 by 5 in both the terms, and you will finally get the relation of final pressure. Fine, which is 2 to the power 7 P naught. A diatomic gas P naught V naught, if final temperature of the gas becomes T naught by 4 in adiabatic process. Find the final volume work done by the gas, change in volume. Okay, so when T naught is actually given, we can't apply the formula PV to the power gamma is constant. Instead we apply the formula which has T itself. Okay, so basically you can apply in two ways. Okay, you can apply either the formula with T and P, or else the formula with T and V. In this case I will choose T and V because it's a pretty simple formula. TV delta minus 1. So yeah, 7.5, and then if you minus 1 you will get 2 by 5. Okay, T naught by 4. Since it is basically they're asking V, you can't apply PT also. So basically you need to apply only this formula. This formula is only valid. So yeah, coming back, apply the same relation. So just put T naught by 4 in the place of final temperature or the T2 temperature, and you get to cancel this. And if you do some basic simplifications which you have learned in like literally earlier classes, you can basically solve this problem, which comes out to be 2 to the power V naught. This is the final volume. What about work done by the gas? It's simple, just apply in the formula, you will get it. Okay, what about change in volume? Change in volume, you can basically get it because you know the final and you also know the initial. You're just gonna minus it and then get it. Fine. So adiabatic compression delta Q is equal to 0. We will be increasing work done by the, so this is analysis. Okay, adiabatic compression and adiabatic expansion, just see these things. Delta Q will be equal to 0 because it's adiabatic process. Delta Q will be always equal to 0, and volume will be decreasing for sure in a compression. So work done by the gas will be negative, and delta U will be increasing because temperature is increasing. Fine. When volume is decreasing, temperature will definitely increase, or else you can also go with the first law of thermodynamics rule also. You can analyze this in the same way, I think. Next is polyprotic process. Unlike adiabatic process, you just need to convert the gamma into X. That's it. Okay, rest all is same. In the place of gamma you need to put X, and that will be called as polyprotic process. So let's see some questions directly. So work done by the polyprotic process is simply nr delta T by 1 minus X. Okay, coming back to the question, P is equal to V square, N is equal to 2. If the gas is increased by 100 Kelvin, find work done by the gas. So P is equal to V square. Okay, if this is in this manner, we need is p is equal to p v to the power something is equal to constant manner. So we just bring it here and we will get -2 for sure, and x will be -2. So in the place of gamma, as we substituted x, it will come like this, and if we substitute the formula, you will get the work done. I think it's not a big problem. For a polyprotic process, again, they're doing something which is really just transferring the value of gamma with the value of x simply. Yeah, I think you can understand this because we have already seen it with the value of gamma itself. And then what about this? Find the specific molar heat. We need to find C. Basically, specific molar heat is C. Okay, specific molar heat when volume is constant, that's Cv. Okay, whenever they ask you to find this, you need to find C. So yeah, they have given this equation taken the form of Pv is equal to constant. Of course, this comes in the other side and you will get -3. See, it's minus. Okay, and x Pv x is equal to constant and x is equal to -3. Okay, and yeah, Cv, where Cv is there, so simply you already know the value of Cv for a monatomic gas, you just put it, and yeah, x value is -3, get the answer. It's not that tough. And this is a formula sheet, and this is taken from one of our legendary teachers. I follow them, they are from the physics wala for sure. Guess the teacher's name in comment box. I mean, the total sheet is taken from them. So basically what he covered in those many hours, I think no problem. P is equal to P is equal to kV square. kV square, 2 moles monoatomic gas, initial temperature is equal to 100 Kelvin. If volume became double, find C delta U delta Q, work done by the gas. Okay, I think this is again an easy question. 2 moles of monoatomic gas, right? So just applying the formula like C is equal to Cv plus R by 1 by X. Okay, we'll get the value of C. We know the Cv value, we know the X value, which comes out to be -2. Okay, we know the work done by the formula of gas, which is directly given as nR delta T by 1 minus X. Okay, n of R delta T by 2, which is the formula of change in internal energy. You can also use that formula. And yeah, delta Q, I think this is an easy question. What about this 2 mole monoatomic gas? P is equal to KT square. If the temperature increase by 10, yeah, everything is given. I think the same formula based question, I think it's easy. So isothermal process, PV is equal to constant, and adiabatic process, PV to the power something is constant. The graphs will be like this. But if they gave a combined graph, how will you find which graph is for isothermal and which the graph is for adiabatic? Well, welcome to the session. Comparison of PV graph in isothermal and adiabatic process. So they've actually found the way how they find the slope, and then they've compared the slope. In this, if you need to understand this, you must know some transformation of graph. But yeah, if you don't know those, simply understand this adiabatic slope will be greater than the isothermal slope. And how many times it will be greater? It will be simply gamma times greater. So this will be, remember this. So yeah, isobaric, it's going to be straight. Of course, it's a constant graph. Isothermal, the next one, and the most slope will be adiabatic, easy. So work done order will be simply this is V, right? So work done order will be simply which has more area below its curve. So work done by the isobaric will be more than the work done by the isothermal will be more than the work done by the adiabatic. This is easy, right? What about pressure? Final pressure order. So again, you can directly see. So this, like This is a question where all the possible ways to attain 2V, not okay. In that thing, which will have more final pressure, of course, isochronic process. Okay, sorry, isobaric process, followed by isothermal, followed by adiabatic. At gas at P naught V naught expand to 2V naught is different process, isobaric, adiabatic, and isothermal. Yeah, I think this topic is important, but I can't complete in this video. So yeah, maybe I will try to post another video, or if you don't have time, you can also like go for any other teachers. But yeah, thank you for watching, and you can actually see my voice is totally changed. That's how hard I work for this. So just put a subscribe button. Thank you.